I'm LaCroix. I'm doing a talk here, Object-Oriented Programming for Beginning and Early Intermediate Programmers. It's very specific because it's pretty specific, and I'm going to try to cram it all in to 30 minutes. But quick disclaimer, Super Mario Odyssey was released last night, so that's me right now. So we'll see how we do over the next 25-30 minutes. All right, so who am I and why should you care? I am a developer. I'm making a video game called MetroNexus. Here it is. While that's running, I'll talk a little bit about my process. I'm an artist first. I'm a designer, a video person. I do motion graphics, and then I do programming because I needed to. And so I became a programmer. And so it took me a while to learn the sort of the proper way to program things. It was all ad hoc and pick it up as I go. So when I tried to learn things, particularly object-oriented programming, I ran up against the sort of the dogma of how you teach it, and none of it made any sense. Okay, so my game, it's coming out soon, I think, probably not. MetroNexusGame.com, sending out betas. I want feedback, so quick plug there. Also, I do a podcast called Nice Games Club. I do this with two friends of mine, Martha and Steven. We're based out of Minneapolis. And yeah, it's a game dev podcast. We do it weekly. We have guests. We talk about design. We take a technical approach, and we take a more artistic approach and a broad approach. And sometimes we just talk about games. So yeah, check it out. Tell your friends, and of course, also yourself listen. If this talk gets boring, just pull out your phone, search Nice Games Club, then you'll have gotten something done today. All right. Quick census on everybody. I want to know what your deal is. Who here is a programmer? Okay, so it's pretty much most people, so this seems about right. Who has tried, and maybe not failed, but tried and are still trying to learn object-oriented programming? Okay, cool. Who has actually used object-oriented programming? At least you know you've used it in some way successfully. Okay, we got a couple of these, so that's really nice. Who's a Unity developer in here? Okay, most people. So I'm not going to really have time to get into it, but the thing about Unity is it's all entity component based, and it uses object-oriented programming languages and concepts, but you don't have to encounter them that much as you make your first couple of Unity projects. So it's hard to learn this stuff in Unity is basically what I'm saying. So that might be why if some of you are having trouble, because of the tools you have don't encourage that sort of thinking. So let's start out with classes. So every document you have, every C# file, every Java file, every ActionScript file, if you're like me, is a class. And classes define objects. So the way it works is a class is just a bundle of code that describes an object that you later instantiate in your code. So the way it works then is that, okay, so first, everything is an object. An integer is an object, a string is an object. These are all objects of a type which is defined by a class. So I don't know if that's new to anybody in this room, but it's something that is not obvious when you just start writing code. But that's the foundational element. In most object-oriented programming languages, you instantiate a new object using the new keyword. So you'll see this a lot. You want variable this equals new this, right? Once you create an object, you assign it to a variable. So creating the object alone isn't enough to become usable later. And then once you create the object, you can then access that object's public instances, or public members, its methods and its properties. A method is just a function. It's a fancy name for a function, and a property is a fancy name for a variable. I was like, what is the difference between a function and a method? I'm missing something here, guys, but there really isn't much of a difference. It's contextual. So here's a quick, this is creating an object. We have a class called foo, and we have two of them, foo1 and foo2, and we instantiate them by saying new foo, and then we feed them an argument. Again, this probably all won't be new to most of you. And then once you have them, you can then access them foo1.publicProperty.publicMethod, and you feed it in. So you only have to write the class once, but then you can have many objects of that class. And that is the sort of core benefit from object-oriented programming, is this modular approach, where you sort of define your objects, and then you go and build your application with those objects. This is the example of the class. That's example in the back there. The classes consists of public and private variables. So if you use Unity, you see this on public variables are what gets exposed in the inspector. Who here is sort of familiar with that process? Okay, most people. And then it's a pretty good metaphor. The thing that happens in Unity, I know when I use it, is I just make everything public so I can access everything in the editor, which is like, fine, I guess. The thing about game development is you don't have to follow all the rules. But that's one of the rules is that your public properties are the way into an object. So objects are black boxes. That's good design, a programming design is you don't want to have all your code talking to all your other code, depending on all your other code. You want basically like the Lego blocks that have the little like connective pieces, and those connective pieces are the public properties. Private properties are used only in that class. They don't exist anywhere else. And that is sort of the main difference between them. There's other types that have to do with inheritance, but we won't really get into that too much. The first method you see here, public foo, right in the middle there, that is the constructor. So that is a function that every class has. And all these are in C#, by the way, so most of you will probably be familiar with it. Java's very similar, ActionScript's very similar, so a lot of the same rules apply. You have a constructor, which is a function that runs as soon as you create the object. So when you say new foo and you feed it an argument, you're feeding the argument to the constructor function. And so that's generally where you put a lot of the, in Unity you have a method called start, which you'll see is sort of pre-filled in. That's not a constructor, but it has a similar kind of real-world function, is that it runs once the object is put into the game. Unity abstracts so much of that stuff. This is a little bit more from scratch than that. So some of you might be familiar with that concept of code that runs once the thing is created. That is a constructor. You also have here this public method that I creatively have titled public method. That is basically just it's just a method on that object. So that is a way to feed other objects and things outside the class into the class without having to put it into the constructor when you define it new. There's millions of examples of why you would want to do this, and I'm not really going to get into like all of that. That's just structurally. I have a note here in my thing. In C#, the convention is to capitalize methods. I don't like that. C# is the only language I'm familiar with. Is there others? Does anyone know others that make you do that? Charles? Java, I don't think does. Now, none of this is part of the language, by the way. These are all conventions, right? These are all like sort of best practices. Anyway, in my examples, I don't do that because that's not the way I've done it, so that might be confusing to you if I'm going against dogma there. Okay, so I have some, I'm like really speeding through this. I hope, stop me if I totally lost you, by the way. Okay, so the way the metaphor I have here is like a restaurant example. So a customer walks up to you, and you are the application, right? Or rather, you're the class. You're the class of this restaurant server, the kitchen maybe, and they hand you their order. Their order is the argument, right? Or is the argument to the constructor, right? They've created a new a meal with an argument of this order. This is the thing I want. You write it down on a little slip, and that slip is your private method or your private property. So that is the relationship between those things. So you see in the constructor here, I have two variables. I have underscore constructor argument equals constructor argument. And that is a thing where the argument that's fed into the constructor is whatever you feed it, right? So this is an integer named constructor argument. Once I have it, it's now data in my code, but it doesn't exist as a member of this object. It's just information that's been given to it, like the customer gives you an order. It doesn't become a member of that class until you assign it to something within that class, the order slip, that you then send back to the kitchen. Because the cook in the back can't hear the customer out front yell their order, because the cook exists in a different method called cooking food or something. And they can't receive that same argument because of scope. And so that is the next bit that we'll get into, which is an activity. So I'm going to hand out, we're not going to have time to do this, but I printed out a sheet that you guys can look at, a little bit of a puzzle. So quickly. I'm pleased and unpleased that I think I underestimated how many to print, so share or take a picture or something. Basically, here the code is on here too if you want to take a look. Basically, it's a couple of classes with a bunch of variables that are all named the same thing, and then your goal, your task is to figure out what equals what. And so there's these debug statements that have little question marks in the comment. And the goal is to know what number those should be. And the reason I've written it out this way is to talk about scope, where an object exists. The solution to it is at this. It actually shows, so you can check your work. Or you can put it into Visual Studio and compile it if you like. That's an option. Anyway, so I'm going to leave that up there for a second. But I'm going to talk about like, why scope is important. This is about making your code sort of modular and separating things out so that you don't just have variable x. Well, x what? Like you have an x on an enemy, you have x on a player, you have a y on enemy, and so on. You have those different properties. You want them to be separated and only matter in the area which they matter. So did everybody get this that wanted to get it? I'll throw it up at the end maybe later. OK, so if you look back in this example, in the constructor argument foo, we have the argument that it's fed, named constructor argument. That variable doesn't exist outside that function. So inside public method, for example, if I were to call constructor argument without the underscore, an underscore is just a convention for saying that it's a private variable. It doesn't mean anything. The compiler doesn't care. But it's useful so that I don't have to come up with new names for everything, because they're basically they serve the same purpose. So yeah, the underscore is just a little signpost. Anyway, if that variable, constructor argument, only exists inside that method, inside the constructor function. It doesn't exist inside the method public method. If you tried to call it from there, it wouldn't know what it is. And that is the sort of, that is scope. Who has anyone written code and you type in a variable and it doesn't autocomplete and you don't know why? Couple of you, this is why. It's that it doesn't exist as part of the scope of that. And scope is generally defined as inside these brackets. So when you have a method, a class, anything that's inside the bracket, so it's very hierarchical. So if you see public class foo has 3 integers. Those are all part of the scope of class foo, which means anything inside that class can reference those things. I don't have it here, but if you were to define a variable like integer, integer player number equals 5 or whatever. If you do that inside of a function, it only exists inside that function. And that's the basics of scope. So the activity that I handed out has a bunch of things where you're calling methods from other classes, and everything is named foo or bar to confuse you extra. And so the idea is to sort of map it through. And if you can unravel that spaghetti, you should have a better handle on how that works. OK, how am I doing on time? Really bad, I imagine. OK, so encapsulation. This is something, it's kind of a twist on what I've already been talking about, but this is one of the main things about object-oriented programming that makes it useful. So everything is in its place. Classes contain all your code in the whole application. Nothing exists outside of a class. Even your main application is a class. It's just the first thing that gets loaded, depending on your compiler and how it works. But even your main game is a class. And that's called encapsulation. Your code is capsuled inside of a number of these classes, and they're all unaware of the code in the other classes. And this is really important because it means that it can be anything you want. It means you can change what's in those other classes without messing up. You can change what's in enemy without messing up what's in level, right? So when your code needs to interact with other parts, they do it through the public methods and properties. There's also event systems. I won't get into that, but some of you probably I imagine a lot of you have used those. But I'm just going to stick to this for now. But rather than calling on the code directly or knowing what that code even is, you have to expose the methods and properties, which themselves are not code. They're just names, right? But that is what other classes, that's how they interact. So that makes a lot of your code safe, so you can tamper with all parts of it, as long as you remember the public parts are the things you need to care about, right? You can have a very messy application that has tons of public properties. Everyone's talking to each other, and that becomes more interdependent and a little bit more dangerous to work with. Or you can have really optimized, like anal retentive code that has just like really tiny little pathways between, which is probably a waste of your time to really build it that way. But you don't want either extreme, basically. So the reason this is important is it allows for abstraction. So I have a couple of examples here. Let's say you have a rideshare app. You want to take on Lyft and Uber because you're stupid. And so you want to create a rideshare app called Rideshare, and you have this new class called Ride. You're creating a new ride for someone. You feed it some arguments, a person, a pickup, and a destination location. And then now that's fine. Inside Ride, you have, okay, I need to contact a driver. I need to prioritize. I need to have a system for error handling in case there's no drivers available. I need to make sure that, that I run a quick check on the user rating, blah, 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 all that stuff. That's all inside Ride in this example. Now, you can change a lot about what happens inside Ride. What you can do is you can say, oh, you know what? We're done with drivers. We're doing self-driving cars now. So all that code about finding the right driver doesn't matter. We just have a self-driving car in every street corner now. Now that's what Ride does. But we're still feeding it the same information, person, pickup, destination. We're just doing something different with it. And then the class form does the same job. It just does it in a completely different way. Let's say we have teleportation now. Well, suddenly we don't need any of that infrastructure, both physical and in the code. But we still need those three pieces of information. So that helps you also determine what your class does, is what information you want to feed it upon instantiation, what information you want to expose as a public method, but that you don't need to define right away. These are all design decisions that will come based on what you want your code to do. So, yeah, you can create a lot of different types of ride. You can prioritize based on rating, travel distance, blah, blah, blah. You want what ride to do is take person.location to equal destination, right? That's the result of what you want Ride to do. But maybe you can be a little bit fuzzy, and the algorithm can work quicker if it's within 2 blocks. Well, you don't have to do that inside of the application rideshare. You can do it inside Ride, right? So that is about abstraction, is that code has no idea what other code does. They just know what I'm telling it to do and what I get back from it. And they just don't have to know about each other. So a slightly more concrete example for game design is, let's say you're working on something and you want to have a player. You have a new player of type player. You want to add it to the scene. Well, that's great. Adding to scene is a great thing you want to do. Now, if you're using Unity, you're not going to do any of this. But while you're prototyping, the player class has a method called add to scene. All it does is draw a square on the screen. Boom, no problem. That'll get me to a playable state. I can play test it with people. They can tell me how ugly it is, and I can move on. But during a beta, now I'm going to have some art on it. So now add to scene has more information in it. And at release, there's also some physics-based cape, and it's a bunch of nonsense. All that stuff happens inside the player class. The game scene never has to change, right? Because it's always dealing with the player, and it always calls upon the player to draw itself or add itself to a scene at the moment you want it to add to it. So the scene is doing a different job than the player class is doing, right? And this is an example. You can organize it however you like. But that's why abstraction is so important. Okay, if you've tried to learn object-oriented programming before, the first thing you've probably heard is about inheritance, is that a truck is a car is a vehicle, right? Now, this is the thing that everybody tells you. This is where I got stuck. I'm like, I get it, but I don't care. And so I'm here to tell you, if you have seen those examples, don't worry about it. Inheritance is an incredibly important part to writing good code, but it's not the most important thing about object-oriented code, and I honestly have no idea why people focus on it so much. But here's a quick example. I have a public class called thing. It has some properties x and y for positioning. It has a method called move, which says move by x or y amount. Great. Now I have a class called enemy, which now, by the way, this is ActionScript code, so it's not going to look that familiar to most of you, but this is what I'm most familiar with. Okay, so now I have a class called enemy, which extends thing. It's a child of thing. So in this class, I can give it a new public variable called hit points, and then in the constructor, I call super. This is a way to call upon the parent. It's different in different languages, so you don't have to worry about the details here. But I can assign HP to the constructor argument, and I can set x and y within the child, even though there is no x or y property on enemy, right? It lives as part of the parent, because an enemy is a thing. And so now I have another type of enemy called Goomba. A Goomba extends upon enemy. And a Goomba now has a function called jump, because not all enemies can jump, but Goombas can. So they have an argument that says how high. And so what you do is, for that function, you call upon the parent move function, and you feed it 0, because you don't want it to move x at all, and you feed it how high is how much y you want to move it. So this is a really simple, dirty way of why inheritance can help you write good code and organize your structures. But the truth is, it's a thing you can deal with later. Like, everyone writes crappy code for I don't know, what's the average, Charles? 3, 4 years after you started, all your code sucks, every single line of it. So you don't need, I think these best practices are great, but object-oriented programming is about encapsulation, abstraction, and scope. That's what, if you walk away with anything, those are the keywords. That's what's important, at least to me and my learning. So, oh my God, I ended early, you guys. My mouth's a little dry. Did we even finish handing out the sheet? I don't know. Okay, so I micro-machined my way through that. We've got 5 minutes. Anybody have any questions? Did I confuse you? Charles. Basic? All right. Sure. All right. So does anybody have any problem they've come across as they've tried? Because a lot of you in here have actually taken this trip, right? You've learned a little bit about it. Hopefully I've been helpful. But does anyone share any of the pitfalls or maybe things that confused them a little bit as they were trying to figure this out? They can sort of share with everybody, yeah?
So here's just a situation that I've never found a good answer to, and it's a pretty common one. You have two enemies, right?
Yeah.
Enemy object, and one attacks the other. Do you say enemy A dot attacks enemy B, or do you say enemy B dot is attacked by enemy A, and do you encapsulate I lose my own health when I'm attacked, or do you encapsulate I take away the other person's health, or do you do one right after the other?
So the question is about, if one enemy attacks another, who is in charge of what happens, right? Now, in my game, in Metro Nexus, I have this problem because I have physics colliders, and the thing about my physics engine is that it doesn't always know who is the collider and who is the collided, and that can change, but if it's the same class, it has the same code in it, right? So I have a whole complicated thing about is being hurt or hurt by others. Maybe this is dodging the question a bit, but the answer to that is that that's a design problem. It's not really a coding problem. The truth is you can put that anywhere you like. And in fact, you should put it somewhere really lazy and inefficient to get started. I mean that truly. And then as you develop and prototype, you'll find bugs, it doesn't work right, but you'll get a working model, and then you'll be like, oh, I get it. This is where I should put it instead. And as a developer, as a self-taught developer, the thing I've learned most recently, is that your code is not precious. You're going to rewrite every dumb line 3 times before it's even a little less dumb. And then you've got 6 more rewrites to go before you would be not embarrassed to show it to somebody. So just start writing the code. If you don't know where it goes, put it where your first instinct is, and you'll be proven wrong very quickly, and then you can change your mind later. I hope that helps a little bit.
Yeah.
All right. All right. Anybody else want to know where to put that line of code? Because I'll give the same non-answer. Okay, you're all experts then. I love it. All right, I'll throw back up the paste bin on the exercise if you want to take a snapshot of that to see how that compiles. And then, yeah, that's it, I guess. We got time to wander to the next thing. Go to get my podcast, Nice Games Club. I'm out of town, so I got to do the hustle for it. So, cool. Thanks, guys.